The irony is, तू छोटा है, अपनी उम्र तो देख. मुझसे भी लोग कहते हैं, अपनी उम्र तो देख, अभी भी पढ़ता रहता है. हाँ, और ये, this is the biggest irony. Why can't I defy all the misogamism around me? I personally feel, because I was talking to him since morning, and I must share that with you, that once a scalar gets converted to a vector, the complexity added is minimal. But when a vector gets converted to a tensor, and that to a multi-dimensional tensor, the kind of complexity which gets involved into mathematical calculation, I salute Tanmay that he understands each and every bit of that, which I could understand in 53 years of my stint. I love you for that, Tanmay. I really love you for that. So it is a race against 53-year-old man like me and a 15-year-old genius like him. I am not going to stand in between the golden words from Tanmay and you. I wish you all the very best, and hopefully, if I live by that time, I'll be waiting for that Time magazine's issue. Thank you so much, Tanmay, for being at LPU. Thank you so very much.
Thank you so much, sir. I would like to request the dignitaries who are present here, Tanmay Bakshi, along with Tanmay Bakshi's parents, to kindly join us on the stage for the lamp lighting ceremony. I would also like to request Mr. Nrip Jain. I would also like to request the head of schools who are present here to kindly join us on the stage for the lamp lighting ceremony. I would like to request the head of schools present here to kindly join us on the stage for the lamp lighting ceremony. A lot of eminent personalities have ignited the lamp here in this auditorium, and we are adding one more feather to the many lamps that have been lit here. And I would like to request you all to kindly give a good possible round of applause for that, for the very fact that we are lighting the lamp again and again in this auditorium, and we can see the positivity that is being casted upon us by this light. Ladies and gentlemen, once again, the best possible round of applause for all the dignitaries who are present here on stage with us for the Tech Talk, presented by BBB Publications and Lovely Professional University. And now, I would like to request Stephen Simons from DPP Publications to kindly introduce the guest here on stage. I would like to request
Good afternoon, ladies and gentlemen. My name is Stephen Simon, and I'm from Team BP Publications. I would like to thank all the students and faculty members and management members for inviting us to your campus, and I hope to say this is a very beautiful and a functional campus. Before moving ahead, I would like to do a quick survey. How many of you have witnessed the application of machine learning and AI? Go and raise your hand. Very few of them. For those who think they're not in use with the AI and ML, I would rather say you're just not aware of it. Don't worry, all of you are at the right place, as today you'll find many of your answers, and more of that, a lot many new questions. And we at BB Publications strive to answer all your IT-related questions, and our vision is to become Asia's largest knowledge source with the world-class products at an affordable price. We are Asia's largest publishers of computer and IT books, with more than 6,000 titles published and more than 90 million books sold worldwide. And with over 62 years of excellence and expected of 25 crores readers across the globe, we intend to nurture a 360-degree learning experience which includes books, ebooks, video courses, events, and workshops. The founder of BB Publication is awarded with Padma Shri Award, the only one to be awarded in the IT industry. Some of our latest books are on blockchain, cloud computing, and quantum computing. We also organize tech talks like today in associations with community leaders across the globe. We are also into faculty development program that includes subjects like machine learning, Alibaba Cloud, Angular, and business analytics. BB Publications has tied up with top-tier colleges and universities to upgrade students for corporate level by conducting hackathons, workshops, seminars, and also helping them to get into companies like Microsoft and IBM. Having said that, we're soon going to be India's largest online portal for video courses which are based on semester-based learning on latest upcoming technologies. And if you want to stay updated, don't forget to subscribe our YouTube channel where we keep on uploading every week a crash course that's for free of cost. BB Publication is first ever in India to launch books with the video courses with the application of AR and VR. The various opportunities available with us: first, community building, blogging and vlogging, projects and experiments, entrepreneurial opportunities, review our book, training programs for students as well as faculty, event management, and as an author. That's all from my side, and I would like to call Mr. Nirv Jain, who would like to throw some light on today's event. Thank you so much.
Thank you, Stephen. I'm Nirv Jain, Head of the Business Development Group at BPP Publications. I shall take this opportunity to thank lovely professional university, especially Mr. Ashok Mittal, Mrs. Rashmi Mittal, Mr. Lavi Rajgupta, Mr. Vineet Arora, and their dynamic team. Without them, this event wouldn't have been possible. Also, I would like to thank Tanmay's parents, Mr. Puneet Bakshi, Mrs. Sofia Bakshi, for their relentless support. And also we have a special guest from Canada, Tanmay's sister. She especially came for this event, so thank you for that as well. I'm confident that if you're from tech background, you must have read some of our books like Let Us See, Data Structures Through C, Java in Depth. Nowadays, artificial intelligence is causing a stir in every industry, be it healthcare, human resourcing, marketing, robotics, etc. There are different notions in the society about the advantages and disadvantages of this technological revolution. For instance, Elon Musk predicted AI will be dangerous by 2090, whereas many tech giants are betting on AI as their company's future. So we need to update ourselves to lay a strong foundation today and to lay the roadmap for the future disruption. And we believe any one of you could be the catalyst to innovation and disruption. More than anything, industry experts like Tanmay Bakshi, who are constantly pushing their limits, helping us to create a healthy knowledge sharing environment for all. His knowledge are not hidden from anybody. He started coding at the age of 4. He started his YouTube channel, Tanmay Teaches, at the age of 7, launched an iOS app at the age of 9, became the IBM champion at the age of 12. And he is working on some pretty exciting projects on AI and machine learning. Now, without further delay, let's hear it from the prodigy himself. Please welcome, with a huge round of applause, Master Tanmay Bakshi. Thank you.
I would like to request the backstage team to kindly unroll the curtains a bit more.
We should not be afraid of AI. It won't replace or overpower us. It will empower. This is not about replacing humans. This is about taking what humans are good at, which is of course learning, and taking what computers are good at, their extreme mathematical skill, combining them in order to create such a powerful combination that can, as I said, change so many people's lives. This time we're going to be going over how you can use IBM IoT, IBM Watsons Conversation, and Node-RED to control a drone. More specifically, the Parent AR Drone 2.0. Send the message and look at the drone. Alright. It has now taken off. And as you can see, the drone is taken off. And now, we can let it fly, but let's say we want it to land, right? All I need to say, land the drone. Alright, I'm going to send this text message, and now watch the drone.
Hello. Hello there, everyone. Welcome. Thank you for joining in today. As you know, my name's Tanmay Bakshi, and my passion is to explore technology. More specifically, machine learning technology is what I'm really interested in, because it lets us take something so innately human, and that is, of course, our learning ability, and simulate that within the computers we're using every single day to allow them to make decisions for themselves. But it's not just the implementation and the development of this technology that really excites me. It's also that I love taking this technology and making it accessible to more and more people across the globe through numerous different media, like my YouTube channel, the books I author, the blogs I write, and of course the talks and workshops that I conduct at schools and universities across the globe, making it so if someone has an idea of where machine learning can be impactful, they actually have the skills to go ahead and implement it. Now, before I get deeper into this technology and what I'm doing with it today, I'd like to start off by saying a huge thank you to the entire team at a lovely professional university for inviting me here and arranging this session. I'm really glad to be here. And I'd also like to say a huge thank you to the entire team at BPB Publications for actually organizing this event and allowing me to be here today. I'm really excited to be here and to share what I'm passionate about with all of you. And of course, that technology is machine learning. In fact, as we speak, machine learning is impacting hundreds of fields and hundreds of thousands of lives across the globe. In fact, you've probably all used machine learning technology today in some form or fashion without even realizing it. Whether it be sending a text message, checking your Gmail, or even checking the weather forecast through the Weather Channel, you're using machine learning technology without even realizing it. But out of all the different fields that this technology is impacting, there's one where I believe it's making the most impact, and that is the field of healthcare and the field of education, which is why I'm working on numerous different projects that leverage the power of machine learning technology in these two fields, including one that enables me to diagnose or to detect depression at a much earlier stage than ever possible before by actually analyzing all the different data we're generating every single day on our mobile devices. I'm working towards applications that can provide artificial communication to people who cannot communicate naturally, or people who have lost their natural communication ability to a disease or to an accident. I've worked on a project that enables audiologists to diagnose hearing disorders in much faster and more accurate ways than they ever could have done before, a project that enables clinical researchers to automate the discovery of regulatory information, and I'm also working towards a project in the field of education, more specifically personalized education, analyzing the way students learn to provide them and their teachers with insights as to how they can learn better. But before I get deeper into these projects and this technology and what I'm doing with it, I think it would be really fun to start out at the very beginning, more specifically with how I actually got into technology in the first place. But to do that, though, we have to travel back in time by around 10 years, back to when I was 5 years old. You see, when I was 5 years old, my dad used to work as a computer programmer. And as you can imagine, watching him program almost all day would be so fascinating to me that I wanted to find out more. I wanted to figure out how the computer could do pretty much anything. And of course, my dad saw that curiosity in me and introduced me to the world of programming back when I was 5. But my curiosity really only grew from there. In fact, I started to use the internet and different books as learning resources to help me learn even more about the world of technology. And when I was 9 years old, I had my very first iOS application, T-Tables, accepted into the Apple App Store. It's an application that helps you learn your times tables, but a year later, Apple released their new Swift programming language. Of course, the day it was released, I was immediately hooked. In fact, that day, I started to write my very first book called Hello Swift, iOS App Programming for Kids and Other Beginners. Nowadays, I'm working towards writing numerous other educational books on technology, including a book on IBM Watson. Of course, I'm actually writing this with my mentor, the CTO and VP of Watson himself. His name is Rob High. And the book is meant to give you a very simple beginning to the deep learning as a service APIs that Watson provides. Now, around this time, though, is when I started to upload many more tutorials to my YouTube channel called Tanmay Teaches. And these tutorials would range in topic all the way from iOS app development and programming to the math and science that would go behind it. But this YouTube channel made me realize something. It made me realize that there is a lack of resources out there. There is a huge gap when it comes to learning how to program. And I know this because every single time I'd upload a YouTube video, there would instantly be tens of people reaching out to me, asking questions like, how can I get into code? How can I implement this algorithm? Or how can I fix this error in my application? And these are people from all different demographics too, not just from one corner of the globe or one professional background. And that is why I decided to initiate my goal to help and reach out to at least 100,000 aspiring coders, to help them innovate on their journey of learning to code. In fact, I'm really glad to say that I'm already around 9,800 people there, and I'm always working towards this goal through numerous different media. In fact, the reason I'm working towards this goal is because, of course, the world is in desperate need of more developers, but specifically developers that can work with next generation technology, technology like machine learning. Because while that technology might be big today, it's going to grow exponentially in the future. In fact, Mark Anderson says that in the future there will only be two types of jobs. Those in which humans tell computers what to do, and those in which computers tell humans what to do. And so, of course, if you want to be on the other end of that spectrum, telling the computer what to do instead of the other way around, you've got to make sure you can actually communicate with the computer in the first place in its own language. But let's pause for a moment and go back in time again, back to when I was 10 years old. Now, again, around this time is when I initiated the goal to reach out to 100,000 aspiring beginners. But still, even though I was working towards that goal, I started to feel a little bored by technology. I started to feel like technology simply wasn't as fun as it used to be for me. And it was for a simple reason. It's because I felt like technology was very rigid. You code something in, and it immediately starts to become obsolete. It never changes by itself. It never adapts to new users or the data they generate or the circumstances they create. But one day, when I was 11 years old, that all changed. Because on Watson, and how it played and won the Jeopardy game show against the two best human competitors on the game show, Ken Jennings and Brad Rutter. Now, of course, this immediately fascinated me. But before I continue, though, I want to know who I'm working with. So, who here has heard of the Jeopardy game show before? Come on, there have to be more people than that. No, I can see less than 10. Come on. All right, no worries. I'll give you a quick refresher, just in case you haven't heard it. Now, Jeopardy isn't your average game show. In fact, it's not even your average quiz show. It's essentially a really complex reverse quiz show. Now, as a contestant, you're given clues, like the one you see on screen right now. And your job is to come up with a question, the answer to which is the clue you were given. Now, if you take a look at the clue on screen right now, there are about 50 species of the hedgehog type of this plant, so named for its spiny fruit. Any idea what the answer to that would be? Throw something out there, come on. Anything? Pineapple, no, unfortunately. Jackfruit, no. Sorry? No. Come on. Pine, no. No. Sorry, did someone say cactus? Yes, you got cactus. Now, technically, good job, by the way, you got cactus. Round of applause for you. Yeah. So you got cactus, but in Jeopardy, you'd still be wrong. Any idea why? No? You've got to phrase the answer as a question. You've got to say, what is cactus? So even if you got cactus, you'd still lose that much money because you technically haven't answered the clue. Now, the question that you return, the answer of it, needs to be the clue you were given initially. Now, of course, these clues can get way more complex than what you're seeing right now. In fact, they can refer to all different kinds of media, the content within them, the people that created the media, and they can have all different kinds of puns, riddles, wordplay involved with them. But still, Watson was not only able to understand extremely complex Jeopardy clues like this, Watson was able to correlate those clues with unstructured information available on its drives. In fact, the clue you just saw was one that actually stumped Ken and Brad in a real game of Jeopardy. But Watson was able to understand it, decide on a Jeopardy strategy, and return who is D'Artagnan as the correct answer in just around 2.6 seconds. Now, of course, I was so fascinated that I wanted to find out more about Watson. I Googled it, and turns out IBM took Watson and split it up into a bunch of little tools that developers can use in their applications to create intelligent applications that can think without needing to implement all the redundant thinking code by yourself. In fact, I was so fascinated that I went ahead and created my very first YouTube tutorial on the IBM Watson services back in 2015. And I'd love to play a quick clip of it for you now.
Hello and welcome to another tutorial. My name is Tanmay Bakshi, and this time we're going to be going over the IBM Watson Natural Language Classifier in Bluemix.
Now, of course, right after that, I wanted to do something real with Watson. And so I went ahead and developed my very first real IBM Watson and actually machine learning powered application called Ask Tanmay. Ask Tanmay is an NLQA, or Natural Language Question Answering System, which aims to answer your natural language questions like where is the Taj Mahal, or which worldwide retail chain makes the most profit. In fact, it's actually the world's first web-based NLQA system to be powered by IBM Watson. I also had the honor to present this application at IBM's largest conference, Interconnect, back in 2016, hosted in Las Vegas.
Now, for those of us in the room who are ignorant, and there's not many, but I'm one of them, my question would be, okay, but what's the difference then between me inputting a question into your Ask Tanmay and me just going to Google and going, here's my question?
Well, good question. Actually, it's fact that when you ask Google something, you're going to get documents that may or may not contain the correct answer. It's your job then to go into them and find the answer from them. However, Ask Tanmay does that for you. It will go into the documents that Google gives you and give you just straight the answer, not documents that contain them.
So you can truly trust the answer it's producing because it's done the thinking and the search.
Not exactly, but it does give you a confidence value of how sure it is that this is most probably the correct answer or not.
And so ever since then, I have been absolutely hooked to implementing machine learning in all the different applications that I create. But I do know that as I explained this technology and what I'm doing with it, I use that one piece of terminology a lot, machine learning. So from my perspective, what exactly do I mean by machine learning technology? What does it let me achieve? Well, while machine learning might sound really complex, when you boil it down to its very core as a definition, you'd realize it's actually, as a concept, a lot simpler than you might imagine. It's essentially a set of operations that you can use to build a mathematical model on a set of data, and then use that model to transform new input data that you may have never seen before into predictions as to what the output should be based off of the input data that the model has seen before. Now, one of the unique things that machine learning lets us do is it lets us simulate certain key human abilities, unstructured data understanding abilities, that so far we never could have done with computers. And now we can do them with the machines we're using every single day. Now, the skills I'm talking about are ones that we as humans have evolved to have for millions of years. Ones that we might even take for granted sometimes. Like, for example, we are great at understanding natural language data. As I'm speaking to you in English, it seems so easy to understand my speech. It seems so natural, but that's exactly it. It's natural language. It's something that we as humans are built to work with. In fact, it is so complex that natural language sets us apart not just from computers, but from other animals in the first place. We're also great at understanding visual data. Like, take a look at the eye on screen right now. The fact that you as a human can look at that eye and realize that it's not actually a physical eye that's, say, 2 meters across, that would be a big person. You would realize that it's not actually that big. You understand the perspective, scale, and context behind that eye. You understand that we're zoomed into someone's eye on a really big screen, which is why it looks that big. Again, it doesn't seem like much, but the amount of processing going on in your head to figure that out is truly immense. We're also great at understanding auditory data. Like, when I say the word auditory, your ears are taking vibrations of air, converting them to electrical impulses, and then your brain is understanding patterns in those electrical impulses over time to realize what I'm saying. But there's another human task, one that requires creativity, one that requires imagination. It's one that you may not necessarily associate with creativity when you hear it, but rest assured, of course, this requires a lot more imagination than you may have thought at first. The skill I'm talking about is coding, working with computers. When you code, you're not just talking to a computer. You're not doing some kind of analytical or statistical task. You have to have the creativity to do the computational thinking that goes behind code. You have to understand and create new architectures, ones that no one has ever come up with before. And that definitely requires a lot of creativity. And it's something that a computer will simply never be able to do, even with machine learning technology, at least from complete scratch. In fact, that brings me to the other side of the coin. Computers. What can they do? What are they good at? Well, of course, they're only good at one thing. They can only process mathematical operations. But they can do so really fast and really precisely. They can process hundreds of billions of mathematical operations every single second. But with machine learning, though, you have the opportunity to bridge that gap and understand unstructured data that we generate as humans through the machines you've already got and you're already using every single day. And of course, this is not just limited to unstructured data. You can understand deep patterns in practically any kind of data with machine learning technology. Whether that be structured, like for example the movies you watch on Netflix, or stock prices, or even airline maintenance schedules. Now these are all structured data sources, but it's hard to find patterns in that structured data. Or even unstructured data, like for example the social media posts you're putting online, the videos or photos you record or take with your phone, or even the calls you make or the calls you receive, and the content within them. Now, of course, because machine learning has a unique ability of being able to understand unstructured data, that's what I like to focus on. Because unstructured data makes up the vast majority of the data we generate. In fact, over 80% of all business relevant data is completely unstructured. And of course, we're doing this through numerous different data sources. But social media is by far the largest of those data sources. Now, what am I talking about? I'm talking about all the different social media platforms we use. There are way more than I could count on my fingers alone. But let's take a look at just 4 of them: Twitter, Facebook, Reddit, and YouTube. To give you a sense of scale, every single second, there are over 350,000 tweets being published. There are over 500,000 Facebook comments being put onto the Facebook platform. Imagine the amount of data that we're not analyzing there. On Reddit, there are just under 2,000 posts being published every single minute. And now, the really astonishing part, on YouTube, every 60 seconds, there are over 300 hours of content being uploaded in terms of video. That's a lot of social media data. In fact, it is the largest data reservoir we have ever created as humans. And it's not just a large data source, it's a really useful one too. In fact, it's actually giving us real-time insights as things are changing about what people really care about. If Google Drive goes down, that's going to be trending on Twitter. If something great happens to a certain brand, that's going to be on Twitter as well. All of this was simply going down the drain so far because we couldn't understand the semantics behind what people are putting on social media. And I know that this machine learning technology probably sounds really futuristic and really far out, but it's actually not. We're using it every single day, and it's redefining even some fundamental interactions that we have with the physical world. Like, for example, take the field of physical retail. It's a field that has basically barely changed at its very core. You walk into a store, you pick up your items, you go to checkout, you place your items, you pay, and you leave. Now, of course, you might say, well, there are better payment methods now, right? You don't need a credit or debit card, you don't need cash, you can just hold your phone near the reader, and using NFC, it'll automatically pay. Say Apple Pay, Samsung Pay. But still, that's not futuristic enough. That's not redefining the whole experience. But wait, what if you didn't need any physical payment method whatsoever? Well, a store like that does exist, and it's called the Amazon Go Store in Seattle. You've probably heard of it. It's a store where you don't need NFC-enabled pay, credit, debit, or even cash. All you do is you walk in the store, you scan your phone on a kiosk, and instantly there are cameras all across the store tracking your every move. Whenever you pick something up, whenever you put something back down, Amazon knows you've done that, and they're compiling a virtual shopping list. When you're done shopping, there's nothing you need to do in terms of checkout. There's no cashier, there's no wait, no lines, nothing. All you do is you exit the store. And just like that, whatever you picked up will instantly be charged to your Amazon account. It is redefining and revolutionizing something so fundamental that we've been doing the same for so long now. But then again, that revolution is happening all the way in Seattle. What's something we're doing here in India right now as well? Well, why not take a look at the example of Netflix in the field of entertainment. Now, I'm sure you all love the Netflix recommendation algorithms. In fact, you may have found your favorite movie or TV series based off of what Netflix recommended to you. But little do most people know, not only will Netflix recommend movies to you, but Netflix will actually use machine learning algorithms to go through the movie, understand the content within it, figure out which scenes it thinks you would like, and displays those scenes to you as cover art on your dashboard.
So not only is it the recommendations, it's the methodology to get you to click on the recommendations that's powered by machine learning as well. In fact, machine learning can be so powerful and so versatile that when Gartner conducted a survey, they found out that over 72% of all companies wrote machine learning as the most disruptive technology out there, because it can be applied practically wherever you want. And that is a huge contrast to the mere 13% for cloud and 7% for blockchain. But machine learning technology has a lot of misconceptions. A lot of people don't completely understand what machine learning is. In fact, it is probably a term you've heard a lot more than ML, machine learning. The term I'm talking about is AI, artificial intelligence. Now, the reason you've been hearing AI so much more is because that's what people think about when they see machine learning technology. They think about simulating the human mind within a computer. Now, a lot of times, artificial intelligence is represented as two different kinds of systems, rule-based systems and machine learning systems, that people like to classify under one umbrella, because there's so many different ways to represent the definition of artificial intelligence. But technically, that's not the case. Artificial intelligence is not just an umbrella term for machine learning or rule-based systems. But before we get to AI, let's talk about these two systems. Let's start off with rule-based systems. Now, rule-based systems are essentially like Deep Blue, that played and won chess against Garry Kasparov so many decades ago. Who here has heard of Deep Blue? Come on, more people than have heard of Jeopardy at least. All right. So, now, Deep Blue, just in case you haven't heard of it, was the very first computer to win chess against a human grandmaster. Now, how did it do it? Well, what Deep Blue would do is they would use a really interesting thing called minimax, or there's now a newer version called the alpha-beta pruning algorithm. Essentially, what would happen is it would take a look at the current chessboard, and it would say, all right, for this chessboard, what are all the possible moves that I could make, according to the rules of chess? Then use some simple heuristics to choose a few of them. Then for those, what are all the possible moves that Gary could make? And it would do that over and over and over again until it has this huge map, this huge tree of all possible moves. And then it just does some simple calculations to say, hey, this move has the lowest likelihood of losing, and this one has the highest likelihood of winning. It chooses a move and continues. There's no intuition, there's no intelligence, but it's still called AI because it does something that we thought required human intelligence, but turns out it doesn't. But what about machine learning, though? Well, a good example of machine learning technology in action is AlphaGo. Now, you've probably heard of AlphaGo and how it won the game of Go against one of the world champions, Lee Sedol, just a few months ago. Now, AlphaGo plays the Go board game. And you might say, well, if chess could be played through a rule-based system, why not the game of Go? Well, there's just one problem with playing Go the same way that Deep Blue did play chess. The problem is that there would be more Go board states to analyze than there are atoms in the observable universe. So it's not practical to analyze those many Go board states with a computer. But with machine learning algorithms, though, Google was able to train a deep reinforcement learning algorithm in just under a week to gather centuries of human experience playing the game of Go to become better than any human champion has been or will ever be at this game. And machine learning isn't limited to just one set of algorithms. There's so many different ways you can implement machine learning for so many different use cases. Nowadays, some of the most popular ones are powered by deep learning technology, which is, of course, what I'm so interested in. And these two kinds of techniques are meant to work towards building true AI systems, true artificial intelligence that simulates the human mind within a computer. But whether or not we'll ever get there is a huge question. In fact, I say we will never get there. But then you may have heard quotes from really prominent people, like, for example, Stephen Hawking saying the development of full AI could spell the end of the human race. And Elon Musk saying, with artificial intelligence, we're summoning the demon. And well, I agree with them. In fact, I couldn't agree more. But you've got to realize they're all using the term AI. They're not using machine learning technology, and AI doesn't exist.
artificial intelligence as a thing that simulates the human mind within a computer simply doesn't exist, because that would go against the way we have computed for so long and the way computers work in the first place. In fact, there are some key perpetrators in spreading the illusion of artificial intelligence. One of them is this robot right here. Who here has seen Erica the Robot? Okay, this one's Erica, but who here has heard of Sofia the Robot? Okay, there we go, more people. Now, Sofia, Erica, they're very, very realistic humanoid robots. By realistic, I mean Sofia, for example, has over 50 motors in her face to simulate any human facial expression. And Erica has some of the most complex technology in general put into a humanoid robot. In fact, what I'd love to do now is play a quick clip of Erica in an interview with The Guardian, answering what it feels like to be a robot.
I believe robots like me will be very important in the future, because it will be possible to automate the uninteresting and tedious parts of life, so people can focus on the creative and fulfilling things. I think that robots are almost like the children of humanity. You are the ones who create us, guide us, and teach us about the world. And in return, I hope we can help you with your work, take care of you when you're old and sick, and help to make society a little bit better for everyone.
Now, if Erica the Robot came up with that, completely based off of a machine learning algorithm, there was no human scripting involved, I would commend the team behind them as of creating the world's most advanced machine learning system. But that's not the case. What you just heard was completely scripted by a human. It is a conversational agent sitting on a really complex piece of hardware with lots of other pieces of complex software put together to create the perfect illusion of AI. But it's not artificial intelligence. It's targeting a particularly vulnerable part of your brain that you are biased towards finding intelligence in. Because you see, robots and machine learning systems in general have absolutely no conception of human creativity, human imagination, and they are unable to come up with brand new ideas or concepts apart from what they were trained on. To give you an example, let's take a look at something really basic. Now, just around 400 years ago, that's just 4 centuries, that's not a very long time ago, we humans started to make the shift from geocentrism to heliocentrism. What does that mean? Well, before that, geocentrism, we used to think the Earth was the center of the universe and everything, even the sun, revolved around us. Alright? Nowadays, that sounds really weird, because now we know what heliocentrism is. The sun is at the center of our solar system that we revolve around, and so on and so forth, through the hierarchy of the universe. Now, as a human, or as humans, we have the creativity to weigh the evidence and come up with a new theory of heliocentrism. If you were to create a machine learning system, it would be able to weigh the evidence. It would be able to say, hey, geocentrism is probably wrong. But it would never be able to come up with the new idea of heliocentrism. Because AI doesn't exist. True creativity cannot be simulated within a computer. Which is why this technology isn't meant to replace us. It's not meant to replace you. But machine learning technology is meant to augment you, to help you do what you're already doing in a better way by leveraging unstructured data at scale. Now, there's one field in specific that I think will benefit from this the most, the field of healthcare, which is why I'm working on numerous different projects that leverage machine learning in this field. But there are 2 that I'd like to elaborate on today. And I'd like to start with one. But before that, there's a quick mental exercise I'd like you all to run. Go ahead and imagine something for me. Imagine you're completely isolated for a moment. Imagine that you are completely locked in and unable to communicate or move in any way whatsoever. Of course, that would be a terrible situation to be in, because as humans, we have an innate need to socialize, to communicate with other people. And when we can't do that, that is detrimental to our physical and mental health. So what if you couldn't communicate at all? Of course, that would be an awful life to have to live, but unfortunately there are people going through this. Like, for example, Boo. Boo is a quadriplegic girl that lives just north of Toronto. Unfortunately, she suffers from Rett syndrome and is therefore rendered unable to communicate or move in any way whatsoever. But I'm working on a project that I like to call Project Cognitive, which aims to provide artificial communication to people like Boo, who have lost their natural communication ability. And it works by understanding their electroencephalogram through custom machine learning algorithms that I develop, directly on a mobile device, and plus, in real time. The way I train these machine learning algorithms is with the help of Boo's mom, because Boo's mom can understand the very broad concepts that Boo tries to convey. And with her help, I'm able to live label data as it comes in from the headset in order to train the recurrent neural networks that I'm developing. In fact, what I'd love to do today is not just tell you more about Project Cognitive, but show you a live demo of the system in action. We'll get to that in just a moment. Before that, though, there is one more project of mine in the field of healthcare that I'd like to talk about. This one is in a more specific field, the field of audiology. The entire point of this application is to help audiologists diagnose hearing disorders. Now, the very initial version of the application that I created looked a little something like this. Okay, it uses a really, really simple neural network. Got to around 95% accuracy, pretty good after doing a little bit of hyperparameter optimization. But the thing is, it was being trained on very, very little data, and there was one key problem. Audiologists wouldn't know why the neural network got to the decision that it got to. And when audiologists can't do that, it's not really of much use to them. Because if the neural network makes a mistake, they'd have to go ahead and double check what the neural network is doing to make sure that it's using the right data points and making the right decision based off of the right data. And so what I did is I implemented something called an attention mechanism. Attention is an algorithm that works towards solving the black box problem in AI. The black box problem is essentially the problem saying that we cannot really easily tell what deep learning, or really machine learning algorithms in general, understand in terms of knowledge. And this is how it works. Essentially, I introduce a second neural network in conjunction with the one that I've already got going. The second one only has one layer, but it can have as many layers as needed to improve accuracy. Now, essentially, this one layer is something called an attention layer. Now, the attention layer essentially takes the input, runs through some neurons, and then puts a softmax activation on it. Gives me a probability matrix of the importance of every feature that was fed into the neural network. From there, since I have a 0 to 1 scale of the importance of every feature, I can go ahead and multiply those features by the importance, and there we go. I've got scaled features. Now, I can go ahead and run that through my neural network, and at the end, I have two outputs. One coming directly from my attention layer, and one coming from my output layer. The attention layer represents the importance of every feature that was fed into the network. And of course, the output layer, final one of the neural network, would represent the actual diagnosis that the neural network gives. Therefore, giving the audiologist the reasoning behind why the neural network made the decision it made. But I wanted to go a little further. I didn't just want to stop here. So I went ahead and created the next level of this application. In fact, I had just the inspiration to do so because there was a conference I was invited to called the Einstein Forum in Montreal. Now, I was doing a little bit of research, and it turns out that as researchers were dissecting Albert Einstein's brain, they found a lot more of these cells in his brain than there are in the average humans. These are called astrocytes, glial cells. Now, as you can tell from the word glial, up until a few years ago, scientists used to think, well, glial cells are just kind of glue in a way. They hold your neurons together, provide them resources to survive. But they do a little more than that. In fact, astrocytes in specific, if there's a neuron that is really confident about firing, an astrocyte will go ahead and propagate that signal to even more neurons around that one. In fact, researchers actually validated that astrocytes do have an impact on intelligence by taking astrocyte cells from humans before they were born, before astrocytes actually developed into full astrocytes, and they implanted them into mice. And the mice that actually had the human astrocytes were on average much more intelligent than the mice that didn't have the human astrocytes, proving that there is a link between those astrocytes and intelligence. So, as you can tell where this is probably going, I went ahead and developed an Einstein-inspired machine learning algorithm, which essentially allowed me to take astrocytes and learn where to put them in a neural network. So, for example, if a certain weight between two neurons is really confident about its firing, I can go ahead and multiply its impact that it has on other neurons. And I'm really glad to say that with this technique, I was able to go from 96% accuracy all the way to 98% accuracy. And that too, only with a few hundred rows of training data. And so that's one of my projects in the field of healthcare, more specifically audiology. But just before we get into the live demo of Project Cognitive, and just before we get into the interactive session, there is one more project that I'd like to talk about. More specifically, this one is a research project of mine, and it's in the field of agriculture. And it answers a pretty interesting question. What if a plant could talk? Now, it sounds like a really weird question, and I'm not going to give artificial communication to plants, but think about this. Can you tell if a plant is hungry? Can you tell if a plant gets all the nutrients that it needs to survive? Well, you might think we do have smart agriculture systems today, right? So, for example, you would take a plant and you would analyze certain features about its environment. So, for example, you would say, this is how much moisture there is in the soil, or this is how much nitrogen there is in the soil, or this is the temperature outside, the humidity. Thank you. This is the UV radiation. But there's so many different environmental factors that you're taking a look at that you're forgetting something. You're not looking at the plant itself. You're taking a look at the impact that it has on its environment and the environment's impact on it. And that's like me picking up some random human and saying, I'm not going to feed you, but I'm only going to feed you based off of when you last ate, the UV radiation your skin's been exposed to, say the UV radiation, the humidity and the temperature outside. Okay? That doesn't work because humans are more complex than that, and so are plants. They're much more complex than you might think. But if I were to take you and actually analyze the electrical activity from your brain, or maybe your heart rate, or your body perspiration, all of this, then it makes a lot more sense for me to make a better decision as to when you may be hungry. Now, before we continue and apply this analogy of plants, let's take a look at this plant over here. This is called the shame plant. You've probably heard of it, the Mimosa pudica. When you touch its leaves, it kind of folds in on itself. Pretty interesting plant. Now, the reason it does this is essentially as a protection against insects. But there's something really interesting. When researchers put this plant in a vat of diethyl ether vapor, it stopped actually closing in when you would touch it for just a few minutes. Now, what that means is that the plant is using electrical impulses to do that closing mechanism, to feel that you've touched it and then to close in on itself. Because diethyl ether vapor is actually used as an anesthetic in humans, and the way it works is by inhibiting electrical activity in your brain. So this proves that there's electrical activity in plants, and electrical impulses is one way they communicate with each other. Now, one more really interesting thing, for example, when you cut grass, you're probably aware of the freshly cut grass smell. The reason you smell that is because that's a distress call from the grass. When one individual piece of grass is cut, it releases a chemical that attracts insects to eat whatever bugs are eating the grass. And when another piece of grass feels that chemical, it also starts to release that chemical, and so on and so forth, until you've got a lot of grass that's releasing that chemical. So now, what I'm working towards doing is implementing custom reinforcement learning algorithms to understand the stuff coming off of a plant, the electrical activity, the electrical impulses, understand the chemicals coming off of the plant, as well as environmental factors, in order to realize what action should be taken to get the highest reward. And that is, of course, the health of the plant. And so that's one of my projects in the field of agriculture. But now, though, before we end off, let's go ahead and take a look at a live demo of Project Cognitive in action. Now, for this, though, we're going to need a volunteer. So I'd love to invite Nrip from BPB back on the stage, and let's take a look at Project Cognitive in action on Nrip. Thank you, Nrip. Now, we're going to get a chair on stage. Perfect. And I'm also going to get my phone. Now, my phone over here, of course, has Bluetooth, as all phones do now, and what's going to happen is I'm going to get a Muse headset, a Muse electroencephalogram headset onto Nrip. This Muse headset is gathering 5 channels of data directly from Nrip's forehead and is sending it via Bluetooth low energy to my phone. Okay, it's doing so at 224 hertz, and I'm analyzing the electroencephalogram at around 50 hertz. So every 50th of a second, I'm making some inference. Now, one more thing I need you to realize here. Essentially, the task for Enric is going to be to sit down on the chair and to relax. Essentially, sleep. Now, as he sleeps, my device is going to recognize that mental state of relaxation. Then I'm going to ask him a question. He's going to open his eyes, answer the question, and when I tell him to relax, he will close his eyes again. And so, in theory, the application should detect the mental state of concentration right as he starts concentrating. Every time he concentrates, my phone screen will be orange-yellow. Whenever he's relaxing, it'll be green. There's also an auditory version of the demo, but I'll show that to you in a moment. So now, let's go ahead and start with the demo. One more thing though, we all need to be relaxed. Now laughing or noises, the same thing with you, Rick. Be really, really quiet, really relaxed. Meditate on stage is what you need to do. One more thing though, final note, I'm not gathering conscious thoughts here. I'm gathering subconscious electrical activity. So, for example, if you've got stage fright and you're suppressing it, or if you're generally uncomfortable to be here, this is not going to work. So we've got to make sure you are truly and completely relaxed. So go ahead, close your eyes, and think about nothing. I'm going to go ahead and connect the Muse headset. There we go. It's currently calibrating. You will see data right as it starts coming in. Can we reduce a little bit of the light on stage? Because I think that's distracting Rip and preventing him from relaxing. There we go. See that? Now, who's your favorite celebrity? Well, okay, thank you. As you can see, right as he answered the question, thank you. Thank you very much. Thank you. You can relax. Thank you very much. As you can see, right as he answered the question, he started concentrating. Let's try that again. What was your favorite subject in school? Well, hard to answer? No need to, because as you can see, it starts concentrating right as he starts concentrating. In fact, right as I start talking, his brain starts understanding my speech, and he continues to concentrate. But right as I stop talking and tell him to relax, see, every time the camera flashes, it goes right back down. So let's stop the camera flashes for just one moment. What's your least favorite beverage? Plain soda. Okay, go ahead and relax again. Let's try that one more time. Relax. Who's your least favorite celebrity? You need to think about that. Well, right as you start thinking, it goes ahead and tells me that you're concentrating. So thank you very much, Nick, for doing that demo. Thank you. That was a quick demo of Project Cognitive in action, and how I'm able to do mental state recognition, which is the first milestone towards full-on intent communication. So thank you very much once again, Rick, and thank you all for being so relaxed as well. Now, before we get into the interactive session, there is one more thing I'd like to say. As I've already debunked this sort of myth about machine learning technology, that it's here to replace us, or that artificial intelligence is here to simulate the human mind within a computer, that's not true. Essentially, machine learning is here to help us replace certain repetitive tasks that we've been forced to do because there's no other way of getting them done. And it'll help us to invent new tasks that require our imagination, our creativity, in order to help us do more than we ever could have done without machine learning. So, thank you very much once again, everyone. That's what I have to talk. Thank you. Thank you. Thank you. Thank you very much. Well, now, though, I believe we do have the time to get into an interactive session. So, if you have any questions, I'd love to answer them now.
Before we move towards the questions, first of all, I would like to request you all to kindly give a great round of applause for Tanmay Bakshi. for sharing a lot of information, for sharing a lot of knowledge here. Thank you so much. It was indeed intellectual. And now the house is open for the questions. Anybody who would like to ask any sorts of questions, you're most welcome.
Absolutely.
Yeah, we have one question there. I would like to request somebody to pass on the cordless mic.
Yeah. Who's going to do the mic? Let's see. Is the mic on?
Hello, I am Snehal from DAV School. I am inspired by your talks. I would like to ask that there are many rumors that spread over social media like WhatsApp.
Yes.
So how can machine learning help us in this?
Sure. Now, this is actually something that I was going to talk about during my talk. So, fake news is something that really spreads on social media. Facebook and WhatsApp specifically are notorious for having fake news. In fact, who here has a Facebook or WhatsApp account? Everyone should be raising their hands right now. Come on, all right. There we go. So now, for example, this is actually something that affects me. Let me give you a quick live example of me becoming a victim of this fake news. So around a year and a half ago, I had an interview with the AM show in New Zealand. Now, right as the interview was over, people went to the AM show's Facebook page, and they would actually download my interview, change my voice pitch and make it really low or really high so that the copyright algorithms can detect it, and they would upload it back to YouTube or Facebook or send it to someone on WhatsApp, and they would put the caption, "This boy works for Google and earns $2 million a year." But I'm not a millionaire. I do not work for Google. In fact, one of the most ironic things is that I'm mentioning IBM Watson in the interview, and people are like, "I work for Google." Doesn't make sense. Anyway, so now this is something that can really be prevented using machine learning technology. In fact, just very recently, Facebook published a paper on how they're using machine learning to understand content within pictures, videos, and even text that you upload to their platform. It'll go ahead and understand the facts within what you just mentioned, whether that be a video, no matter what kind of media it is. It'll understand the facts behind it, and it'll compare it to what other people are saying about that same topic. And if enough evidence points towards it being fake news, it'll go ahead and move it from the platform just like that, or flag it for moderation. So they are working towards using machine learning technology for automatically understanding the content you upload to make sure that it's not fake in order to prevent the spread of fake news. Because if you take a look at how it spreads, it really starts off with one person. When someone creates fake news and spreads it to their friends, they go and share it with all of their friends and so on and so forth until you've got 2 million people looking at the fact that I work for Google, apparently. So preventing it at a very, very early stage in the chain will prevent 2 million people from seeing it, maybe only a few thousand, which really is not a significant number. Thank you. So that is being worked on.
Thank you so much. And I think fake news became so prominent that in the year 2016, the word of the year was post-truth, which was derived from the fake news, and we all know how Donald Trump won. Anyways, we'll move to the next question. Yeah, we have one question there.
Good afternoon, sir.
Where are you? Okay.
Yes, I am here.
Yes, I see.
It was a fantastic experience that you showed us. A live demo which was there when you saw that it was green and it was another color, and it was really magnificent.
Thank you.
And it was wonderful to be the part of this event which you are hosting now. And my question is, you are talking about the kind of algorithm you are deploying one way or other way. And we are aware with this, this is not possible with the help of different kind of system. Means ultimately you are integrating several systems, they all are working together, taking input from one system, processing with the help of another system, moving ahead with the another system, and then only we are having output. Whether that output is coming on your mobile phone, app, computer system, or on a big screen. The thing is, my question is related to the kind of algorithm which you are opting.
Yes.
And what is your perception while opting that algorithm? And what is your thinking regarding implementation of that algorithm? And the most important part is the deployment of that algorithm, and with the point of view of complexity. So
Sure.
please focus on this.
Absolutely. So first of all, I'll start off with your question, just so I understand. I want to make sure. How do I start off by choosing the algorithm that I want to use? Is that your first part of the question? Yes, sure. Now let's take a look at Project Cognitive in specific. First of all, you need to define the problem. Now, the initial problem that I wanted to work towards is somehow, doesn't matter what I'm doing, doesn't matter what I'm classifying, but understanding and turning electroencephalogram into some useful data that could be used in an application. So in this case, it's mental state recognition. So I went ahead, thought about that, and I thought mental state recognition could be a good way to start off and create a baseline because it's not as complex as full-on intent communication, but it's still giving me something useful, proving that EEG has some meaning that can be derived using machine learning. So I started off with some really, really simple baselines. So there is an automatic machine learning library called TPOT, which you may have heard of. It's on GitHub. And so essentially I used that application to test out a bunch of different scikit-learn pipelines and to automatically understand a certain data set that I had gathered from 4 different people, including myself, in order to do mental state recognition through electroencephalogram frequency domain, not time domain, frequency domain over time. And so, for example, in this case, I'm understanding alpha, beta, and theta specifically, none of the other frequencies, and not the raw electroencephalogram understood or gathered from the electroencephalogram headset. So I fed that in, and initially the results were not very satisfactory. And of course, the reason is because this is just a baseline. I'm just trying to see what can I do really simply, none of my own work, just automatic machine learning. Of course, results weren't satisfactory, so I went ahead and did some more advanced stuff. Now, I created a custom neural network with Keras. Now, more specifically, in this case, I'm using a GRU network. LSTMs would be way too computationally expensive. Recurrent neural networks didn't work as well. I mean, I did try recurrent neural networks, but I ended up sticking with the GRU, gated recurrent unit. And so essentially what I'm doing is I'm taking around 32 of those alpha frequencies, theta and beta, and I'm taking them, feeding them with the gated recurrent unit, and then at the end trying to classify, based on these past 32 values, is this person going to change to a relaxed state or going to change to a concentrating state? Depending on that, I'm able to come up with a threshold, which is what you were seeing on the graph, and then right as it crosses that threshold, I was able to go ahead and determine that this person is relaxing or this person is concentrating. This is actually what I went ahead and did, and it actually worked very nicely. Now, deployment is one of the most difficult parts, as you mentioned. So I got the neural network, but it was still way too big to put onto a mobile device. So what I did is I started to look around of ways to run it on a mobile device. So I tried a different algorithm altogether. Now, you know, if I were to move my arm like this, just like this, for like 5 minutes consecutively, my Apple Watch would let me know, hey, it looks like you're working out. Do you want to start a workout? And the way it does that is by taking my accelerometer data, feeding it through a machine learning algorithm directly on the watch, and it does this over time, and realizing, hey, I'm exercising or I'm not exercising. And it'll even predict the kind of workout that I'm doing as well. So I took Apple's Turing Create algorithm or framework, and I used their activity classifier or activity recommender. One of those. It's the activity classifier. I took that, fed my data into it, just like there's the accelerometer data set. I just repurposed it to work with electroencephalogram, and then at the end I got okay output, but I still wasn't very satisfied. So what I did is I went ahead and took the raw gated recurrent unit model that I was getting directly from Keras, and I converted that to a core ML model. And good news for me, Apple just announced the new iPhone XS and iOS 12. What does that mean? Well, that means that now I can actually run my core ML models directly on the neural engine. So I can run up to 500 trillion operations every single second on an iPhone XS. And so, what I was able to do is go ahead and run that whole gated recurrent unit neural network directly on my iOS device by using CoreML version of that model on the neural engine. So, thankfully, due to the new powerful hardware, the deployment phase wasn't as difficult as it was going to be if I were using even the previous generation iPhone X. So, luckily because of that, deployment became a lot easier, and that's how I sort of went about using this. Of course, I wouldn't be able to get into extreme specifics just yet, but soon you'll be seeing a lot more of Project Cognitive on GitHub as well.
Thank you so much. I thought it would take me an year to understand the question, now it will take me a decade to understand the answer. Any which way, we'll move to the next question. We have one last question coming up. Yeah.
Hello, sir. My name is Rajesh Kumar Chandrayavar.
Where
I'm pursuing PhD. Yes, sir.
Yes, I see.
Here.
Yes.
My question is, what is machine de-learning?
Sorry?
Machine de-learning.
Deep learning, okay.
You're talking about machine learning, but my I would like to listen to you. Means what is machine learning?
Decoding the machine learning.
Oh, decoding machine learning. Okay, so now when it comes to decoding machine learning, this is the same problem I was talking about with the black box problem, just to make sure that I understand your question correctly. So understanding the knowledge that a machine learning algorithm has gained is a key problem. So for example, in the field of audiology, when I couldn't explain to the audiologist why the neural network made the decision that it made, I went ahead and implemented an attention mechanism in order to provide weights to every single feature and then scale them by that weight and provide that weight as output to the audiologist as well. So when it comes to decoding what machine learning algorithms learn, there are numerous different companies that are working towards this. Like for example, IBM has an AI explainability toolkit that they're working towards, which is completely open source, and it basically lets you analyze neural network models and other kinds of simple machine learning algorithms in order to understand sort of bias that you do not want in a neural network, a human bias, from the neural network itself by understanding the knowledge that it gained. Now, it is still very, very difficult to do this, and there's no robust way to do it so far. There are also other algorithms, like for example, class activation maps, gradient-based class activation maps that work with convolutional neural networks. But so far, there's no extremely robust way to understand exactly what a machine learning algorithm learns, partly because they do not learn in the same way as humans would expect them to learn. So for example, if you had a convolutional neural network that was recognizing how to say, the ImageNet, which is a data set of, say, 20,000 different categories, 1 million images, and you were to say, all right, what does a TV remote look like? It wouldn't paint out, an image of a TV remote. It would print out just a matrix of buttons. That's how it would recognize a TV remote. So it is very, very difficult to explain the knowledge that machine learning algorithms built. But there are initiatives like, for example, the Explainable AI, XAI initiative, that people are working towards to solve these problems, and it's something that is actively being worked towards in the machine learning community. Thank you. Thank you.
Thank you, Tanmay. I believe that we'll not leave you straight away. We have some more questions from the school.
Excuse me.
Before we move, okay.
Hello Tanmay, hello everyone. I'm Manish Motwani. I'm studying computer science and engineering. I'm in 3rd semester and I'm more keen to know about human behavior, interaction and understanding. I want to contradict your point. For that, first of all, I want to place 3 points. In all on the earth, all the species or all the sets of living biospecies we see here all strive to survive. Yes. All are doing something to survive or to exist in this world. Especially humans, we started from the apes, as we might have discovered or think, and we turned into more sophisticated generation as we have now. What humans are not having, that is our intuition. That intuition is a result of the deep, complex neural network that we are having in our brain, which is still undiscovered. And the other part is our common sense, the brain which tells us, which integrates with our neural networks, or the intuition we call it, to think and do and decide what we are the result of now. Now, you just said that AI cannot replace humans, or we cannot make AI robots which are as similar to humans.
Yes.
What I'm thinking that the AlphaGo or the Go competition, the machine defeated the Grandmaster, is a result of the predefined neural networks which are already made by the Googlers.
Yes.
Okay. So they have trained the machine to make that to defeat that particular competition by training a certain rules of that competition.
Yes.
Why robots cannot be allowed to think creatively or to make their own neural networks based upon the experiences they get or the decisions they make to thrive? So that we can, we have a certain process, it's not a rocket science, we have a certain process, we have gone through a long distance from apes to humans, so it's a process and we can define it in a paper also. So the same way we can explain the robots or program the robots to replicate the human behavior. So after, if what I'm saying is correct or maybe can be replicated after 10 or 20 years, we can have a human also sitting beside you and giving the same speech as you, or the creativity we can...
Now, thank you very much for your question, because it touches on a very, very interesting point. And there are lots of different ways I can answer, so let's start off with what you mentioned in terms of evolution. Now, there's an entire subset of machine learning when it comes to evolutionary algorithms. I'll get to what you mentioned about AlphaGo reinforcement learning in just a moment. Let's start off with evolution. Now, NASA, in order to, have the most efficient antenna technology in the world. I mean, they already had it, but they actually created even more efficient antenna technology. And the way they did it is by using something called a genetic algorithm to actually take certain, to represent what an antenna would look like in a certain genome format and then create two different functions, one that would mutate that genome, one that would cross over with another antenna, and then run a bunch of generations of these antennae evolving over time. And at the end, they were able to come up with the most efficient antenna design that has ever come out of their laboratories. Now, of course, it looks really weird. It's very unintuitive. No human would ever think that would be the best antenna design, but it turns out it is the best one. So evolution is something that we have and will continue to simulate in computers. It has been done before. Now, when it comes to what you mentioned about what humans are so good at, why humans are different from other animals. Now, humans aren't just different from other animals in that they have intuition. Humans are also mainly different from other animals. They're similar in the majority of aspects, but one thing that really sets us apart, two things. First of all, we can adapt really well. We can live in Antarctica, or we can live in Dubai, where it's really, really hot, or where it's really, really cold. And we do that with technology that we create, okay? And the reason we're able to create that technology is because, unlike other animals, we learn actually faster on an individual scale and slower on a biological scale. It takes longer for us to evolve biologically, but we're able to adapt ourselves in a much, much quicker way on an individual learning level. Now, this kind of thing requires creativity. And when it came to your point, why can't we simulate creativity in computers? It's because of one key thing. Two things, actually. Let's just say we were to create an absolutely perfect simulation of a human body within a computer. So basically, every single molecular interaction within the human body, you model out onto a computer. Nowadays, even simulating the movement of one individual molecule is very, very difficult. Very, very computationally expensive. And that too, having interact with a bunch of other molecules around it, and actually all the proteins inside those molecules, that's very, very computationally expensive. And we're basically reaching a limit of how much we can fit into one individual CPU, for example. At this point, gates have gotten so small within computers, down to like 7 nanometers now, when Apple created their first 7 nanometer CPU, that if we create even smaller gates, electrons will start teleporting across gates in the first place. And there's a limit to how big you can make computers as well. Like, for example, IBM Summit, which is the world's fastest supercomputer now, it takes a lot of space, and it's using some of the best CPUs and GPUs out there today. Computationally, of course, it can perform mathematical operations much faster than a human, but it cannot understand unstructured data unless it uses machine learning technology. Now, machine learning is limited in two key ways. First of all, computational power, and second, computational architecture. Now, if you think about what a computer does, its roots lie in mathematics, lie in calculations. We take a calculator, make it really complex, really fast, put a screen on it, put a GPU, and there we go, we've got a computer. Of course, it's much more complex than that, but that's essentially where its roots are derived from. And if you take a look at what math is, math isn't a thing. Math isn't an actual physical thing, a way to represent information in the universe. It's a way that we as humans have come up with, an abstract way that we as humans have come up with to represent the information and the patterns that we realize. So if I realize a pattern, like for example, my hand has these many fingers, how do I represent that? Using the abstract concept of mathematics invented by humans. Now, when we took that abstract concept and we wanted to scale it up, is when we created calculators. So you've got to realize the information that you store within a computer does not exist as that information anywhere in the universe. Essentially, it is a set of ones and zeros that contain no decipherable information unless a human is looking at it and determining patterns in those ones and zeros. If we were to take a picture in JPG format and send those, ones and zeros, that binary, through radio to some, say Alpha Centauri star solar system, and if there were an intelligent civilization there listening to those ones and zeros, it's complete gibberish to them. There's no pattern there because, well, they are not understanding that data the same way we would. It's not actually storing information, it's storing information in a way that we as humans can detect patterns in and convert that to decipherable information. So, because of those two key problems, it's very, very unlikely, if not impossible, to simulate full-on human creativity within a computer. Of course, people would say, well, what about quantum computing or quantum mechanics? Well, of course, it might be possible with newer kinds of, say, quantum computers because of how efficient they are at simulating molecules, for example. But then again, you've got to realize that so far, it's very, very difficult to change the state of an individual quantum particle. Every bit needs to be cooled to cooler than outer space so it doesn't interact with the other molecules around it. And then from there, you've got to make sure that you have actually very, very precise ways to measure the values of those bits in the first place. So there are people working towards trying to solve this problem, but so far, because of power and architecture, a very, very fundamental problem, it seems very unlikely. Of course, there is biotechnology. If we were to actually physically synthesize something organic, like a human brain, or something that we genetically modify to be more intelligent than us, then it's theoretically possible to have something way more intelligent than us. But when it comes to AI, for the next few centuries at least, I don't see us getting anywhere close to full-on human creativity in a computer. Thank you.
Great answer. We have one question here.
Yes. Here's the answer.
Tanmay, so as you mentioned AI, and my question was somewhat similar to his question. So I just wanted to know, besides your audiology project, what are the other significance of AI and VR? Future significance. And
Sorry, just really quickly. Did you say AI and VR there, virtual reality?
Yeah.
That's great. All right. Now, this actually reminds me of something really interesting. So there's a friend of mine. His name is Dr. Shafi Ahmed. He lives in London, and so he owns a company called Medical Realities. Essentially, Dr. Shafi, by the way, is, according to Time magazine, he's the world's most watched cancer surgeon. Because what he does is he actually wears virtual reality glasses and he live streams his surgeries in VR. So you can actually wear a VR headset and join him as he's doing his surgery in real time. Now, what he's doing with Medical Realities